Keller and Marion Breland, former students of B.F. Skinner, who built a successful business training animals for commercials using pure operant conditioning, encountered a bizarre and persistent problem. Raccoons trained to deposit coins into a container would instead repeatedly rub the coins together in their paws, as if washing them, actively resisting the very reinforcement schedule that should have eliminated this counterproductive behavior. This discovery, instinctive drift, revealed hard biological limits on operant conditioning that pure behaviorism had not anticipated. Keller and Marion Breland, in their influential 1961 paper, The Misbehavior of Organisms, documented numerous cases from their professional animal training work in which an animal's learned, reinforced operant behavior gradually drifted over repeated trials toward instinctive, species-typical behavior patterns. Even though this drift was never reinforced and actively worked against the reinforcement schedule the animal was receiving. Raccoons trained to deposit coins into a container for food reward increasingly rubbed the coins together between their paws, mimicking innate food-washing behavior, despite this behavior delaying or entirely preventing their food reward. The Brelands documented instinctive drift across numerous species and training contexts beyond the well-known raccoon example, including pigs trained to carry large wooden tokens to a container for food reward, who instead increasingly dropped and rooted the tokens along the ground with their snouts, mimicking innate foraging behavior, and chickens trained for simple behaviors who similarly drifted toward instinctive scratching and pecking patterns, demonstrating that this phenomenon was not an isolated quirk but a broader, systematic pattern across species with strong innate behavioral programs relevant to feeding. Instinctive drift posed a direct, empirically grounded challenge to the strict behaviorist assumption, prominent in early 20th century learning theory, that the general laws of conditioning applied essentially uniformly across species and behaviors, with any arbitrary behavior potentially conditionable in any organism given a sufficiently well-designed reinforcement schedule. The Brelands findings instead demonstrated that an organism's evolved instinctive behavioral tendencies could actively compete with, and in some cases ultimately overpower, operant conditioning's reinforcement effects, especially when the reinforcer itself, typically food, was closely tied to a strongly relevant instinctive behavior pattern. Instinctive drift is closely connected to the broader concept of biological preparedness, the idea that organisms are evolutionarily predisposed to learn certain associations far more readily than others based on their evolutionary history and ecological niche. Just as taste aversion learning occurs unusually rapidly because organisms are biologically prepared to associate taste with illness, instinctive drift occurs specifically when a trained behavior conflicts with a strongly prepared, evolutionarily significant instinctive behavior pattern related to that same reinforcer, such as food handling behaviors intimately tied to feeding and foraging instincts. Contemporary learning theory has integrated the Brelands' instinctive drift findings, along with related biological preparedness research, into a considerably more nuanced view of animal and human learning that recognizes both genuinely general-purpose conditioning principles, which do apply broadly across many species and situations, and important species-specific biological constraints and predispositions that shape which specific associations are learned quickly, slowly, or resisted. Altogether, replacing the earlier, simpler view of learning as an entirely general-purpose, unconstrained process applicable uniformly to any organism and any behavior. The discovery of instinctive drift has directly informed practical animal training methodology across zoos, service animal training programs, and entertainment industries, which now explicitly account for a given species' instinctive behavioral tendencies when designing training protocols, selecting reinforcers, and setting realistic expectations for which behaviors can be reliably and durably trained versus which behaviors are likely to be undermined over time by competing instinctive drift, particularly for behaviors closely connected to feeding, foraging, and other strongly evolutionarily significant behavior patterns. Instinctive drift stands alongside taste aversion learning as powerful evidence that learning is not a single, universal, general-purpose process applied uniformly across species and situations. It is a process constrained and shaped by each organism's evolutionary history. The Brelands raccoons, stubbornly washing coins instead of depositing them, revealed a fundamental limit to pure behaviorism that reshaped learning theory for good.